So today I'm going to show you two examples of using bar models to solve real-world problems. So the first problem we have is the one that you see on the screen now. It says that two diamond rings and four silver rings cost $1,440. A diamond ring and a silver ring cost $660. How much does a silver ring cost? So when we look at this problem, the first thing we want to do is pull out the information that they give us. We know the total cost of two diamond rings and four silver rings. So our bar is going to represent that total cost. Okay, we also know that within that bar, we have two diamond rings and four silver rings. The D represents the diamond, the S represents the silver. We also know that one diamond ring and one silver ring cost $660. So in order for us to find how much a silver ring cost, we need to fill in the remaining missing parts of our bar. So if we know that a diamond ring and a silver ring cost $660, we recognize that those two pieces go together, and this one will also be $660. So if we put those two pieces together by adding or multiplying by 2, we now know that two diamond rings and two silver rings cost $1,320. We now have two silver rings remaining without a cost associated. So we have a total and we have one part. In order for us to find that missing part, we can find the difference. That tells us that two silver rings cost $120. Now our question asks us how much one silver ring costs. So if we know that two silver rings cost 120, we can divide 120 by 2. And we find that one silver ring would cost $60. Our second problem is one that we call a before and after problem, where we use before and after bars to answer our question. This question says that Logan and Izzy had the same number of stickers. After Izzy gave him 72 stickers, Logan had 3 times as many stickers as Izzy. How many stickers did they have altogether? So our keyword after tells us that we need a before bar and an after bar model. The information that is given to us is that before Izzy gives away any stickers, Logan and Izzy have the same number, so their bars will be the same size. The next piece of information says that after Izzy gave him 72 stickers, Logan had 3 times as many as Izzy. So Logan will have 3 parts, and Izzy will have 1. Now, our question wants to know, how many do they have all together? When we look at our after bars, we have to reflect back to our before and ask ourselves, how many of Logan's parts would need to return to Izzy's bar to have them be equal? So if we have 3 parts for Logan and 1 part for Izzy, that tells me that one of those parts is worth the 72 stickers that Izzy gave away. Because if we move 1 part back to Izzy, Logan and Izzy have the same number again. We can use this information to find our total. If 1 part is worth 72 and we have a total of 4 parts, 3 for Logan, 1 for Izzy, we can multiply 72 times 4. So Izzy and Logan will have 288 stickers all together. Our final problem is one that does not use a bar model. This one uses critical thinking and a little bit of strategy. So it tells us that Mikhail used 220 inches of wire to make this figure. The figure is made up of 2 identical triangles, a 15-inch by 12-inch rectangle, and a square of side 19 inches. What is the length of one side of each triangle if all the sides of the triangles are equal in length? So to start this problem, we have to use what information is given to us, and then we can fill in the blanks. So if we know the length and the width of our rectangle, we can easily find the perimeter. We also know the length of the square. And what we know about squares is that all sides are equal. So we can easily find the square's perimeter. We also could have used multiplication, doing 19 times 4, which would also have given us the 76 inches. The other piece of information that's given to us is that Mikhail used 220 inches of wire to make the entire figure. So in order for us to find how much wire is left over after making the rectangle and the square, we need to subtract that from the total. So now we know that both triangles needed 90 inches of the wire in order to make them. So we have a total of 90, and we have two triangles with 3 sides each, a total of 6 sides. Because we know that all of the sides of the triangle are equal, we can divide 90 by 6. That tells us that one side of the triangles equals 15 inches.